Hey everyone, and welcome back to the channel. Today, we're diving into one of the universe's most enchanting mysteries, the twinkling of stars. You've probably looked up at the night sky countless times, mesmerized by those distant pinpricks of light dancing and shimmering. It's absolutely beautiful, right? But have you ever wondered why they do that? Is it magic? Are the stars winking at us? Well, not exactly, but the real science behind it is just as fascinating. And trust me, it's going to make you appreciate that starry sky even more. So, let's peel back the cosmic curtain and explore this celestial phenomenon together. The short answer to why stars twinkle, while planets generally don't, lies right here on Earth, specifically in our atmosphere. Yes, our very own breathable air is the secret ingredient in this cosmic light show. Imagine a star, billions of miles away, emitting a steady, unwavering light. That light travels through the vast, empty vacuum of space in a perfectly straight line, completely undisturbed. It's a true beacon, constant and bright. But then, it hits a roadblock, not a physical one, but our planet's atmosphere. Our atmosphere isn't a smooth, uniform blanket. It's a dynamic, turbulent, and constantly moving ocean of air. Think of it like a giant, invisible swimming pool that's always swirling and rippling. When the light from that distant star enters our atmosphere, it has to pass through different layers of air, each with varying temperatures, densities, and pressures. These variations cause the light rays to bend and refract ever so slightly. It has the same principle that makes a spoon look bent when you put it in a glass of water. Light is changing its path as it moves from one medium to another. Now, because our atmosphere is never still, we have winds, convection currents, heat rising from the ground, cold air sinking. These pockets of air are constantly shifting and churning. So, as the starlight zips through these turbulent layers, it's constantly being bent and redirected in slightly different directions before it reaches your eyes. This continuous bending and shifting of light makes the star appear to change its position, brightness, and even color very rapidly, creating that mesmerizing twinkling effect we call scintillation. It's like looking through a warped window that's always moving. The star isn't actually moving or changing. It's our atmosphere playing tricks with its light. Isn't that wild? So, why don't planets twinkle? This is a super common question. While planets are also far away, they are much closer to us than stars. Because they're closer, planets appear as tiny disks of light in the sky, not just pinpoints. Imagine that each of those tiny disks is made up of millions of individual points of light. When the light from a planet enters our turbulent atmosphere, each of those individual light points gets refracted and jiggled around, just like starlight. However, because the planet is an extended source of light, a disk rather than a single point, the wiggling of one part of the disk's light ends to be compensated by the wiggling of another part. So, while some parts of the planetary disk might be momentarily dimmer or brighter, or slightly shifted, the overall effect averages out. Our eyes perceive the planet's light as relatively steady and unwavering. It's like looking at a large picture through that warped window. While parts might distort, the whole picture remains largely coherent. That's why planets typically shine with a steady glow, while stars appear to dance. Another factor that influences how much a star twinkles is its position in the sky. If you look at stars that are low on the horizon, they tend to twinkle much more dramatically than stars directly overhead. Why? Because when you're looking at a star near the horizon, its light has to travel through a much thicker slice of our atmosphere to reach your eyes. It encounters more air turbulence, more density changes, and more opportunities for its light to be bent and scattered. Think about it. A longer journey through that turbulent atmospheric ocean means more chances for those light rays to get tossed around. Stars directly overhead, on the other hand, have a shorter, more direct path through the atmosphere, so their light experiences less atmospheric interference and they twinkle less intensely. This atmospheric turbulence also has a significant impact on professional astronomy, especially for ground-based telescopes. While twinkling stars are beautiful to us, they are a huge headache for astronomers trying to get clear, sharp images of distant celestial objects. The constant distortion makes it incredibly difficult to focus on faint galaxies or pinpoint the details of a nebula. This is precisely why observatories are often built on high mountaintops, far away from city lights and above a good portion of the densest, most turbulent atmospheric layers. The higher you go, the thinner and more stable the air becomes. This is also a major reason why we launch space telescopes, like the magnificent Hubble Space Telescope or the incredible James Webb Space Telescope. By placing telescopes in orbit, completely above Earth's atmosphere, they get an unobstructed view of the cosmos. No atmospheric twinkling, no distortions, just pure, pristine starlight and cosmic wonders. That's how they capture those breathtakingly sharp and clear images that fill our screens and science textbooks. So, the next time you gaze up at the night sky and see those stars putting on their dazzling show, remember it's not the stars themselves doing the dancing. It's our own dynamic, living atmosphere, interacting with light that has traveled unimaginable distances to reach us. It's a beautiful reminder of the incredible forces at play, both near and far, that shape our perception of the universe. From the microscopic particles in our air to the colossal furnaces of distant stars, everything is connected in this grand cosmic ballet. Isn't that just mind-blowing? The universe is truly full of wonders, and sometimes the answers to its biggest mysteries are right here on our home planet. I hope this explanation has given you a new appreciation for the twinkling stars and the incredible science behind them. If you enjoyed this cosmic journey, please give this video a big thumbs up, share it with your friends who love staring at the stars, and definitely subscribe to the channel for more fascinating explorations of the universe. Your support helps us bring more awesome science content to you. Thanks for watching, and I'll catch you in the next video.